Welcome to Frequency Matters, the RF and Microwave Update Series. I'm Pat Hindle. I'm here with my co-host Gary LaRude. As you can see, we're back in a remote setup here, and we're shooting from different locations. So going forward, we're going to do a combination of episodes in the studio and some remote.
Yes, my wife and I are moving to Opelika, Alabama to be closer to family. Opelika is a town of some 30,000, about a 90-minute drive southwest of the Atlanta airport. Opelika neighbors the town of Auburn, which is home of Auburn University, which I'll add offers a bachelor's degree in wireless engineering.
So going forward, we'll do a combination of co-hosts locally in the studio and then some remote shooting with Gary and I doing the co-hosting. So in this episode, we're going to take a look at our September military and aerospace issue. The cover story is written by Mercury Systems, and they talk about how integrating open firmware standards, open software, and open hardware provide the ability to rapidly prototype and speed up the production process. We're seeing a big move for this standards with SOSA and VITA in the military side and Open RAN and Open RF on the commercial side. So it's definitely a big move for all trends in every area. So Gary, what do we have for technical features?
Well, we had one other article in the issue. It's an interesting overview of the COSPAS SARSAT Satellite Distress and Safety System, a very important global system that we don't hear too much about, except when people are rescued in distress. And how about product features?
So we had one product feature, and that was from Signal Hound. They have an affordable 43.5 gigahertz real-time spectrum analyzer. It has 160 megahertz of bandwidth and 110 dB of dynamic range. It also doubles as a vector signal analyzer at a very affordable price, so it's quite the product. What did we have for tech briefs?
Well, we have 4 tech briefs, believe it or not, from Pervisus, a software-defined radio which has storage. It can be used for spectrum monitoring, recording, and playback. Then from Menlo Micro, it's a reconfigurable filter for military radio systems using high-power MEMS switches. From M-Wave, we have efficient combiner networks for SC and X-band power amplifiers. And finally, from IQ Analog, an antenna processing unit for all digital radar, EW, and communication systems. This has 30 gigahertz instantaneous bandwidth using what they call a data conversion architecture with traveling pulse wave quantization.
And speaking of interesting products, I saw that Cubic Nuvotronics released an E-band filter, and it's built with their Polystrata technology. Polystrata is an additive manufacturing process, so it allows for very fine features, has very good filter performance and minimal part variation, and results in a great production reproducibility. The interdigital filter has a passband from 81 to 89 gigahertz with a 50 ohm characteristic impedance and handles a maximum of 2 watts. And the Polystrata process is low insertion loss in a surface mountable form, has 3.6 dB maximum of loss and a passband rejection of 40 dB. So quite the high performance filter. It's good for E-band satellite communications, RF telemetry, and instrumentation. And they're one of the many RF and microwave filters that are available from RFMW, our sponsor for this episode. So turning to the news, I saw that OneWeb had a couple of big partnerships that they announced. The first was with AT&T, and they'll sell capacity to rural areas so they get better coverage. And then I was at the satellite event, and they announced that they were also teaming up with Hughes Network Systems. Same deal, they'll be able to switch between terrestrial and satellite to give a combination of better coverage for people. And they did a great demo there. They did some high capacity video and showed that they could seamlessly switch between the terrestrial and the satellite links. So very interesting developments. Good to see that OneWeb is getting some things out there.
Definitely. So news from my standpoint, we've talked all year about the accelerating pace of acquisitions. I noticed a couple in this recent period. First of all, Murata bought Ada Wireless to acquire its digital envelope tracking technology for mobile phones and IoT devices. And you may recall that Nokia actually acquired the first incarnation of Ada devices to apply the ET technology to improve base station efficiency. Then we also saw that TE Connectivity bought the longtime antenna supplier Laird Connectivity, and that will extend TE Connectivity's antenna portfolio to include IoT and wireless devices at the edge of the network. And then one other item, I think last time or time before we noted that Nokia had paused its work with the O-RAN Alliance. Well, they've restarted it now, saying the pause was only to ensure that the alliance was complying with U.S. export regulations. So they're now back engaged.
Well, it's good that the Open RAN efforts continue, and it wasn't a very big pause.
Right.
So, turning to events, I attended a satellite show in DC recently. And I think the most interesting development that we saw there is the approach of flat panel scanned arrays. There were several companies on site who are offering these, and they all take kind of different approaches. You have Chimeta that uses their holographic beamforming using a metasurface. So that's a very unique process. ThinCom uses a rotating three-layer setup, so they can rotate these apertures and get beam steering, which is another approach. And of course, Ball Aerospace, they're kind of using the traditional electronic phased array approach that uses active chipsets. So that's very interesting. And then I kind of saw three that I consider newcomers, even though they've been around a few years. There was Cesium Astro, and they take a modular approach. So the array is in a one module, and then they have like a computing module, a power conditioning module. It's pretty cool that you can switch these modules in and out for different frequency ranges. Then there's Nexcom, which is commercializing fragmented aperture antenna technology that came out of Georgia Tech. And this promises to offer a very low-cost PCB production type process to lower the cost of these array searing beams. And there's also Opticists who had traditionally used 3D printing to make antennas, but now they're offering a full array. And what's unique about their system, it may be a little bit thicker than some of the flat panel ones, but it can do multiple frequencies in one setup. So that was very interesting. So how about you, Gary?
Well, a couple things. I moderated our latest panel session, this one discussing defense trends and how they're driving the requirements for RF microwave technology. It was a great discussion. I thought I certainly learned a lot. And if our viewers missed it, you can watch a replay that's available at the Microwave Journal website. Also, in events, we're watching what's going to happen now with European Microwave, which is scheduled for February in London. You can expect to see that registration is going to open in October, and hopefully we'll be able to meet in person in London come February. And that's it for this episode of Frequency Matters, which is brought to you, as Pat mentioned, by RFMW, a pure play technical distributor that represents the leading RF, microwave, and millimeter wave products and the companies developing them. Thanks for watching Frequency Matters and being part of the Microwave Journal community.